Okay, good afternoon. Now today we are going to start one of the important session, and that is Python for data science. And in this, what we are going to cover is a case study. In the previous session, what we saw is what data science is all about. And we saw the basic concept of data science. So let me tell you what we saw in the day 2 session. It was all about what data science is. And in that we saw like data science is a technique by which we can extract the data. And this data which is extracted is from something which is a structure or unstructured data here. So here data science plays an important role. So you can extract data means from, it could be any data. Now here, let's say data is in the form of Excel or CSV or anything. So that all we saw in the yesterday example also, like how we can extract data now. Today we are going to see a real-time case study where we are going to extract the data. Then we saw the role of data scientists and what the role of data scientist is, how what is the qualification of data scientists, what all skills are needed. All these things we saw in the yesterday session also. Then we saw like the which are the tools are there, because data science is something which is a tools or technique by which you can extract and get the insightful data from that. So these all things we do with the help of data science. So now which are the tools are available in that case? So we saw the tools like NumPy, Pandas. They are very useful tools available in the data science now. Using NumPy, what we do is we can create a array. You can create a multi-dimensional array. And this multi-dimensional array is something where you can do certain manipulations. You can get a, you can, give the shape to that array. So what is that array? Array is also a kind of a data, right? Like when you say Excel data or CSV data is a two-dimensional array data, or you can say it is a two-dimensional data, and it has a rows and columns. Array means it has a rows and column now. And when you talk about two-dimensional means we have a rows and columns. So one X and Y axis here. When you say three-dimensional data means it has a X, Y, and Z. So these are the three columns are there. So there are three things in the case of three-dimensional. So yesterday we saw like how to create one-dimensional array, two-dimensional array, and three-dimensional array. So we also saw various methods by which you can create array, like using the method like ones method, zeros method, arrange methods, and many more. And then we did a various manipulation on the array itself. Like array manipulation include some, like the sum of the array, mean of the array, or getting the max value from the array. So all those operation also we did on the array itself. And yeah, we also perform some operation like reshape the array. All those things we are done. So we are having a, let's say previously one-dimensional array. We converted that one dimension to the two-dimensional array also. So we saw like ND method by which we can find out the dimension, shape method by which we come to know the shape of the array, like like 10 by 10 or just 100 comma. So those kind of examples so we saw in the yesterday session. Now after that, what we saw is the Pandas. Pandas is a very powerful library. It's a very useful library for data science here, which allows you to perform the operation on two-dimensional data. So two-dimensional array is a Pandas here. So when you say two-dimensional array means your Excel, CSV, those kind of data, or any data where we have a rows and columns. So we have one thing is rows and another thing is column now. So that those kind of data comes under the, or even the matrix. If we talk about matrix also, that matrix is a two-dimensional data. So the library like Pandas allows you to read those kind of data. You can read data or you can perform the operation. So it has two things. One thing is a series. One of the method which we saw, under the Pandas, one of the class which is available is a series itself. So what is series now? Series is something which is allows you to create, you can say one-dimensional array, or you can say it's like a dictionary. So it allows you to create a one-dimensional array or a dictionary. So by which you can perform the operation on homogeneous type of data here. Let me tell you, like again, I told you like one difference between the array and the case of list also. In the list case, what happened? List means you can have any type of data. It's a collection of any type of data. Whereas, or you can say sequence of any type of data. That's a thing in the list case. But when you talk about the array means you have a similar type of data. Means that's what homogeneous type of data. That is also we saw as a difference between the list and the array here. Then we say like, okay, now we understand, okay, the different types of data also we saw, because in array we need to understand the different types of data. So it is an integer array, or it is like a float array, or you have a string object type of array. So we saw varieties of the type. And again, in the integer also, you may have a 8-bit integer, 16 bit integer. So it depends on the size. So we also saw like, the what is the number of byte it is there. And also we discuss about the various function like size function, by which we come to know how many elements are there in the case of array. So that's what again that all basic thing. Now array or NumPy, this is a library which is a basic library for, or it's a fundamental library for data science, you can say. Why I'm saying fundamental library? Because now when you talk about your raw data, when you talk about data, so it has certain dimension, and you need to perform some operation on that data itself. So whether it is cleaning the data, or data wrangling, or data mungling, whatever transformation you want to do, all these things we do on that some dimension data only. So you perform some action on certain rows or column. Now when you talk about series, is a one-dimensional data now. It has a one dimension, so it doesn't have in x and y, and you can perform the various operation on series of data. So like there's a time series, so that you can perform the operation. What difference we saw between the series and the array is, in a series case you can pass the parameter as a list also, you can pass the parameter as a dictionary also, and it has an index by default. That is what we saw in the case of series example. And then we perform some operation on the series by passing the dictionary also, and we saw, okay, what type of data it comes in the series, and then we can update the series. All those operation we saw in the case of series, like how we update the dictionary, same way we can update the series. So this was something which is a brief. I'm just giving the brief idea of what we already saw in the previous workshop, means yesterday's workshop. I will request to all of you go through that yesterday workshop so that understand the concept part, because I'll be using this library like Pandas library here, and specifically I'll be using the data frame here for solving the case study. Then we saw the data frame, where we saw like data frame. Using the data frame, you can read the CSV file and you can have the data frame. You can create data frame using the CSV file, or you can provide the data in the form of, like, let's say multiple dictionary as an input, and create the rows and column. So what is the object of data frame is having the data in the form of, let's say, either you can say like a table. You can imagine data frame like a table, because you're already aware about table, means table is having the rows and columns. So data frame is like a table, you can say, and it has a rows and column. Now you can do what? You can perform the operation on, like SQL, you perform some operation. You can access some rows data, you can access some portion of the data. That all thing you can perform data frame also. So if you want to extract some data from data frame, maybe some portion of that also you can do it. So data frame is like a table, and on the table, whatever the operation you want to perform, whichever the type of operation you perform, all that you can perform using the object oriented principle of Python. And this data frame class, like Panda, it comes under the module Pandas. And now here you can think about, okay, I want to access the rows, I want to access the column, I want to access the index. All that you can do with the help of data frame itself. So yesterday we did a lot of hands-on session using the data frame. We saw, like, we zip the two list, and we combined the list, and we created one data frame. All those operations we did, and then we converted that into the CSV file also, and then we also plot the data. All these things we did in the yesterday's case study. Okay, now today it is very important session, and as I say, our main objective is to do something on the real-time data. Now we can download some data. I will show like from where to download, how to download, and then how you can perform various operation on some data. So you can get data sent from the site called Kaggle, and I'll tell you from how to download that data, and then perform the various operation on that data using the Pandas library. That is what we are going to do in the today's session. But prior to that, I would like to conduct some theory session also, so that you understand how data science works, how the data, how do you extract the data, how do you get the data from the various sources, and what is the complete process. So that life cycle also I would like to take it before we go ahead with the today's session. We'll also have some concept like what the descriptive statistics or informative statistics, so data cleaning, mean value, standard deviation, correlation. But it all depends on time. I will try to cover this concept also. Some other things I can take it, but because it is very huge topic, so to cover each and every topic will not be possible in detail. But then in practically we can do something like, we can you can try to get the standard deviation. In the case study we'll see what all things are possible, or will if the time permits, yes, definitely I will try to cover the this topic also. Okay, now let me come to the today's agenda. So here, okay, the other library I'll be using now for this, like the NumPy, Matplot, and okay, so let me start with this. Okay, so here, what is the key objective of data science is to process, is to extract the data. So let me come to this point. Okay, this is what the example I will show you now here. What we do in the case of data science, what is the process? So understand, like the process here. Like this, all the statistician, what they do, they have some, they would like to find out, let's say in the class, let's take the scenario here that you want to do some research work, and research work could be a very simple example. You like a height and the weight is a data of the person. Let's say you have a data which is in the form of height and weight, and you like to say find out based on that data, based on the data of the height of the person and the weight of the person, the obesity, whether the person is having the obesity or not. Okay, so you would you like to predict something like, okay, the person may have obesity or may not obesity, but then what data you are having? You have, let's say, data of 10,000 people, and that data you want to find out, as you are asking the question based on this data, having the knowledge about, let's say, height and the weight of the person, and there could be some male or female also, that also you have category in that case. So you may have one categorical data that is a male or female, and then you have some numerical data. Let's say height is a numerical data and weight is a numerical data. Now you like to find out whether the person is having the chances of obesity or not. So obesity is like about the person who is a highly weighted. So if it is highly weighted, generally there are chances of obesity, right? So that is what we say obesity in the medical term. Now this, how you can identify this is all, and how many person. Now the next question would be, okay, if you have a 10,000 data, out of this 10 data, how many percentage of the people may have chances of obesity? You want to predict it well in advance before even you take the treatment. If you find out, okay, now there are, based on the 10,000, whatever the data you got, as that we call the sample data. So it's a sample data, and from there you're asking the question, I would like to find out now how many people is having the chances of the obesity. That could be the one of the question. The second question you may have may comes as a, this is just like a population data, and that comes, okay, now if how many are the male in that, and how many are the female who is having the chances of obesity here. So these are the interesting question, and you are doing some analysis. This is a very basic question. These are the very basic data I'm asking. You can take any data. This is just like one sample I'm talking about. Now here, this is, so to ask that question, you require some data, right? So how you can collect the data now? You can ask some, you can collect data from population data from someone, or from maybe you can visit some site where the healthcare site, where you may get data about the person regarding the height and weight. So or maybe you can visit somewhere childcare, and there you are getting some data, and you're finding out, okay, how many people is having the obesity, or maybe the for child you want to find out. Okay, again, next question would be, how many of the child is having the chances of obesity now? First you are asking about the person, then you want to go for the male or female. The next question could be, okay, now how many child is having the chances of obesity now? So these all questions, asking the question, and now based on that you, okay, now I need a children data also. I need the data of all the population. So this is the way you are collecting data. So now you said, okay, now I want the main data also, I want the female data also, I want the children data also, because your objective is to find out at what age there are. Again, next question could be, at what age there are chances of obesity. And mostly, which are the people is having the more obesity? Again, next question could be interesting question. Which type of people is having more obesity? Are the people who are working people? Are the people who are doing the job? Are the, or again, you may have some interesting question. Are these guys are the software engineer is having facing the the obesity problem? So you can have any question, and these all question you can find the answer. So you have your questions in your mind, and you're so curious to find out who are the people, who are these guys, who are the people who having the chance of it, because now this is a very important data. Now you are finding out, and this information which you get it from the data, if you extract it, if you extract that information, that is what data science. And if you say there are 10% child in the data population data is having chances of obesity, what you can do in that case? You can give the data those about those 10% people, and you can take the action before anything happen wrong, any kind of a health issue occur. You may take a precaution, you can give the guidelines, you can help to the maybe you can give that information to the doctor and say, okay, you should call these people and you have business now. There are chances. Actually, this is the way you can, the doctor, they can find out. There are people, they generally, ask you, okay, we will give the, free, BMI report. Why they are doing the free BMI report? This is all data collection way. You are just collecting some data. And from that data collection, you can give that statistical information that to certain doctor, and then doctor will give the some suggestion, or someone may contact you, maybe the gym instructor may contact you. Okay, there are, so these are the way the business is done. So why we are discussing this, let me tell you, all these businesses are based on some statistical data. So you, let's say you first thing is you get the sample data, then now you explore the data. What is exploring data means? Like, okay, now I got the data, which is, I don't know what the data is in the numerical format, data is in some in a categorical format, or we can say text format. I have varieties of data now. It's a raw data, right? Now when you have raw data, we have something which is unknown. We don't know exactly whether it is data of height, or it is a data of age, or whether it is a data of the sex, or whether it is a data of the category could be of professional. What type of data it is, you're not aware about it. So you need to first find out, you need to plot the data. For that we require certain methods, for that we require certain tools. Let me do in Pandas case, you can do that. You have a Pandas library, allows you to read the data, allows you to find the stat also. You can perform some statistical operation on it. And we have another library called Matplotlib also. In the Pandas, so we can plot it, as well as there is one more library called Matplotlib, by which you can visualize it now. You can see how many males, how many female, how many children is having the challenge of obesity here. So this is the way we do the exploring of the data now. So you plot it and you just see the patterns, and how we can even based on the the visualization also, you can decide, you can take the action. So your next action will be based on what are the visualization or the pattern which you have right now. Now you first thing is you did what you did exploring data. You gather the data, you explore the data. Okay, so that is what we are done, and you have visualized the data. That is what exploratory data analysis, right? So the next thing is now you want to predict something. You want to predict something. So how you can predict? So for predict, you need to give that training data. Now this is something a data which is a clean data. Now you did what in the exploring in the case of Pandas, you can clean data. You may have data which is not necessary that you have all the information correctly written in the what is the sample data you talk it. So you may have some missing value in that case. So what you will require to do in that case, you will require to remove those missing value. Remove those anything which is again, these are chances like you may have data which is something which is integer type, you may have data which is of float type. So the varieties of data will be there. So you have to find out whether the data is correct or not. So whether it is accurate or not. So that first you need to do that cleaning data and filtering data. So all these things we call data wrangling and mungling. That is what we explore. But then once you have done that, what is the next part? Next part is to train the model. Now that comes into machine learning. In the machine learning, you have the models which allows you to predict something. You want to predict based on the height and weight how many people is having the chances of the chances of uh, any kind of disease. Okay, so this is like a input data, and now this input data you are trying to find out the output, right? So this is what so you may have the various model. They are now what are the machine learning model. You may have linear regression model, logistic regression model. Depending on the question, you will require to select the model. Then so model, it is not like same. It is not like like in all situations. Doesn't mean that you'll be using only linear regression here or logistic regression. It is based on the question. Somewhere we have decision making model, somewhere we have just like a linear regression model, where you just need to, based on the input, you want to find the output. So that is what where we say the build the model and fit the model and then validate the model. So what we do in that case, in the case of machine learning, we are training the model here. We are training the model, and we also have we do what we divide the model into two data set. One is called training model data set, another is called the test model data set. So test model is something which is just 20% of your data set. So that is only for testing the model only. And based on that, you can predict. So this is the entire process of data science. I hope you understood like how data science process is, because before we practically do it, I want you to understand the process itself and why we are doing all these things. And okay, so this is what we discuss now. We collect the raw data, we process the data, we do exploratory data analysis where we visualize the data, we find, okay, how many males are there, females are there in graphical way, in visualized format. We clean the data, because some cases, I just say like you may have data having some missing value, or you may want to fill some with a new value. So all that operation can be performed in the exploratory data analysis itself. And once it is done, you can train the data by you can create a model of it. Means you are training the algorithm here, and then you may again predict something. So this is what the way the data science works. So the decision, because see now here in this case, as you are giving the training to the model, the model will tell you, okay, that what action should be taken now. So decision is based on the model now here. The prediction is based on model only. Even like in the case of Pizza Hut, let me do Pizza Hut. If you know the diameter of the pizza and and the size of the pizza, you can say. So this based on that, if you want to find the price of the pizza, and then there's one more Pizza Hut want to decide the price. So if you want to decide the price of Pizza Hut, pizza itself, how you can decide the price of the pizza? So that is again based on the input data and the model, whatever the input you are giving, you can predict here. Okay, that was all about theory part. I think it's a big theory, so I will not. I'll now come back to the practical part here. Meanwhile, you can write your questions, whichever the questions are there, and we'll come with the anaconda here now. I have a numerous case study, but then I have to just decide which one to be taken in the data science. I was just thinking like which case study will be more useful for all of you guys. This was yesterday's thing, so let me come back to the. Okay, there are various types of data set I have now. It all based on data, and then I'll tell you like how to even how to do this practically, from where to get data and how to do data analysis. All these things I'll explain. For example, you have a data set where it is related to admission now. Now, if you have something data set which is telling you to predict the prediction of the graduate admission from Indian perspective, whether there are the chances of getting the admission or not, if you want to predict. So that kind of data set, there is a one data set is available called admission prediction. So I'll tell you from where to get that. So you need to go for the data set that is a Kaggle site for that. So let me share the screen Kaggle site here so that you know, like there's a site called Kaggle, and from where you can collect the data. So I'm just sharing you the site here so that you understand like from where you can get the data now. Okay, so you have the site. You may require to register in case. This is the site where you can get the data set now. You decide now which data set you want, and you can search. So here it could be a data set of admission predict. I just did what? I just say I wanted to have the admission predict data set. From here, you can download the data set. So here there are data set available, like you can see here, there's a data set available. And once you have the option, here there's an option to download, right? Once you download, you will see that, you know, some data is there. This is all for, you know, for the trial. You can take the any type of data. You may have a sales data, you may have a something which is a data set as per your domain, you can say. So you decide your domain, and based on the domain, you can download the data. And this is all sample data for practicing purpose. I can see some question here. Let me check it if any question is there. Okay, so okay, so now I hope you got the site. Remember this site, Kaggle site, is very useful site for collecting the data now, so that you can practice on it. So here you get the data. You can see there are files available, and we have to now these are all CSV file. This is the admission predict.csv file having these are the files which are there, and you can download from here now. So I already downloaded here. Just now I downloaded so that I can you know, take the case study here. So let me show like how to then read it. Once you download, you can keep it into folder now. So I have downloaded and put into one folder, data science case study. So I'll be opening the notebook now, and in the notebook I'll show like how to read the data then. So let me show you the notebook having the admission data. Okay, so this is something like, let's say data. Once your data, then you find out about data. What data? Because let's say I have data now, but I don't know anything about data. Right? Let's say this is just the raw data, and this is the data which is related to admission. That's it. I don't have any idea about it. So if I do not have any knowledge about the data set, what I know is that it's a data set which is created for the prediction of graduate admission from Indian perspective. And you know, like the admission is very expensive. The master degree in the USA, specifically for Indian guys who are trying for the master degree in USA, is very costly. So we need to see like, is there chances of, you know, getting the admission based on the what is the score you're having. So you may have some score available, like someone guys may have a GRE score out of 340, TOEFL score is there, let's say out of 120, university rating is out of 5. Then this is what your input data now, and this is a data set of admission data set now. Now the consulting company, they may require this data to find out whether which candidate is having more chances of getting the admission for the master degree now. Now, I'm a consultant, let's say. I'm a consultant. I would like to advise some students whether you will get the admissions to some particular college as per your choice or not. So this is something you want to predict. This is your problem statement. Now, how you can predict that someone can get the admission or not? For that, it requires some statistical data, some data which will help you to predict something. I hope my screen is visible to you. So here, this is the data set, and we'll be now exploring step by step, and we'll understand how actually to read it using the pandas here. So this is the data here right now. So here, this data set will help you, all the students, shortlisting the university with their profile now. So your profile data is there, and then the predict, it will predict the output, which will give the idea of getting the particular university or not. So this is what the main objective of this particular data set now. Now, what are the library I'll be using here? Here, mostly I'll be using the Pandas library, but some cases we may require to use the visualization of data. For that, Matplotlib will be used. Some cases, NumPy library. Some cases, Seaborn library is all for visualization. And as per the need, other library can be used like CS and OS. Now, what is the way you can read the data? To read the data in Pandas case, now if you have imported Panda as a PD, Panda as a PD is something which is like alias you create. Yesterday we saw like the case study here. So Panda as a PD, and now you are reading the data here simply using the read_CSV. Now what I did is I put the the file into that particular current working directory. Otherwise, you need to give the path of the file here. Now here separator is by default also comma. Even you don't mention the comma here, it will work. So by default, even in the read_CSV, it is a separator which is a comma. But in case you have a data, let's say where a comma separator is not there, you have some space also, then in that case you require to give the space then. So here there is something which is an optional parameters here as a comma. Now here what we are doing is we are creating data frame. Now this data frame is again is a very huge thing now. So to know like how many, I did what after reading this df is data frame, I thought to know the shape of this. So what I did then, I find out what is the shape. Means what the shape means here, how many rows are there and how many columns are there. Yesterday we saw in the case of data frame that data frame is having the rows and column. So when you say df.shape, it tell you the how many rows are there here, 400 rows, and there are 9 columns now. Now this is very important to understand that how many columns and what are those columns are there. To know that, what I did, I find out the top 5 rows here. And to get the top 5 rows, I just use a df.head now. So df.head is to get the top 5 rows here. So you can see the top 5 rows here now. Now so this is to give the quick idea about data here now. What data is all about. So here I came to know there's a serial number, there's a GRE score, there's a TOEFL score, university rating, and all those things. Now, this is the basic information about dataset now. So there are 9 columns having serial numbers, GRE score, TOEFL score, university rating, SOP, LOR, CGPA, research. So these are all the things we were discussing, right? Here we were discussing about what is there here. What is SOP is a statement of purpose. University rating, letter of recommendation and strength, recommendation strength, undergraduate, CGPA score, research experience, and the chances of admission. So research experience is 0 or 1. So whether you are having research experience or not. So we will see now which particular column. Now here it is very important to understand now which particular columns makes more sense for prediction now. Whether it is a GRE score, whether it is a TOEFL score, whether it is a university rating, whether it is a undergraduate score or research experience. So which is deciding the admission chances. So we have to find out now. So when there are more chances of admission. So here you can just find out the more chances. That's the only thing we can do it now. So here we have this data now. Now there are 9 columns, and the chances of admit, there are no records. It's good. There are now 400 samples in total, and that is enough for us right now. Now, okay. So now what you want to find out that how many columns. So we have 9 columns, and you are just printing here the various columns names which are there. They are the column name now. Now here, what you can do is if in case you want to modify, once you have read the data, you can perform the various operation now. You want to first let's say column name you have right now, there's a chances of admit is there. In case you want to give the new names, that also you can do it. So these are like various operations we can perform. It is based on the requirement you may require to perform the operation now. Now what is important in the case of data here? Now, as we have data which is very clean data right now, so you may not have a any null value. If the data is very clean data, you may not have null value. But we should always check whether this particular data frame, which we just got it by reading the data, is having any null value or not. So if it is a null value, then how many null values are there? That also we have to find out. So that's why the sum. So null value in the type. So here we can see the result that there is no null value. Okay, this happens only when the data is already clean and it's already available, which is with a it's a clean data right now. But this doesn't happen in the real time scenario. In the real time scenario, you may get the raw data having the lots of data which is having the null value or missing value, you can say, and that missing value you need to find out that how many rows or columns are empty there. So because you may require to remove those empty columns or empty rows. So this is all we can do with the help of your data frame method itself. So here I'm finding out is null. So it is saying that df dot is null, and same it is saying that all are now here 0. Means what does it means? Not a single row or column is here empty now. Okay, now you want to go for the understanding your data itself. So how you can understand data now quickly? So for that we have a descriptive statistics here. So what you do for that, we find out about data including all the columns now. So here I'm finding out all the columns. What we are finding out, what is the sum of the data, or what you can see the mean value of data, what is the standard deviation, what is the how many records are there. So I can get the first thing, understand each and every rows here. The first row in this, the result, when you say df.describe, is telling like number of rows. So whether I'm getting all the rows here, yes. So in the real time, you may not have all the rows. You may have some rows less or more. So you can find out then. Okay, whether any row is empty there. So if there are empty rows, you may not have that, the count also. So as in this case, the data is very clean. You can see here there are 400 rows, and the mean value for the GRE score, for the TOEFL score, for all that, you can see there is a mean value available here. And then we have a standard deviation. It's a deviation. It's like from the mean value, what changes there. Then we have minimum value, and we have a percentile value here, and the max value also. So these all things we can find out using the existing data right now, and this is all done by only one command, and that is df.describe. And we are just saying that we would like to see for all the columns here, right? So this is the next step. We did it by simply. Then we want to find out the type of data here. Why? Because now if data is numerical type, I can perform the numerical operation. If data is of categorical type, means I can perform the categorical operation. So here you can observe that the data which is there here, mostly data is of integer type and some data is of float type. So this is what the observation for every column, like serial number, GRE score, TOEFL, all this, it comes into the integer column. University rating, whereas SOP, LOR, CGPA. So this one, SOP, LOR, as well as, so this comes under the float values. And here this one is research one is again integer value. Chances of admit, again you can see is a float value here. So this is what we come to know about the data here now. We did a head and tail here to get the, okay, there are two functions available. One thing is a head. Head is something where to get the top 5 rows. The another function is to get the last 5 rows. So when we use it, let's say we find some discrepancy in the data, and so in that case, mostly what happened, last rows are empty. So in that case, you want to find out, okay, which are the rows which are empty in that case, and in that maybe some specific column data is empty. That you can quickly find out using the df.tail also. So this kind of method can be used to find the rows, the top rows or the bottom rows here. Next thing is you want to drop, let's say now here there are very important thing, like which one you want to find serial number. Now you do not want to do anything on the analysis. You don't want to take the serial number for the analysis purpose. your objective is to take the GRE score, TOEFL score, those kind of column, not the serial number. So you can replace, or you can drop that particular column and create your own data frame now. So this is all possible. You can create a data frame by dropping the serial number here now. So you can see because you can see here when we saw here, there's one more column is there, right? And this is removed now. So we have now the data which is pure data where serial number column is not there now. Okay, so this is what the data after dropping the. Now what is axis 1? See, there are two things. One is x is equal to, let's say, 0, and the other is 1. 0 is for your rows and 1 is for column. This remember now. So if you want to remove the column, you have to say x is equal to 1. Now, if you want to find out the correlation between all the columns, how these columns are correlated to each other. Is there any relationship of GRE score with a TOEFL score, with a university rating, SOP, LOR, CGPA, research, and chances of admit? That's the most important one. Which are the columns are connected to the chances of admit? This is what we want to find out now. How you can find out? You can find out the relationship of each and every column with the chances of admit. And if there is a relationship which is related to 0 or 1, so whenever there is a correlation, if it is it could be a minus or it could be a +1, right? So we have to see or there's no correlation. When you say correlation is not there, means it's 0, right? It's a null, right? So we have to find out that. How we can do it now? For that, you can use the method you can create a subplot of this your data set itself. So for that, okay, first thing is we are doing we are creating one complete figure size. Here figure and X is something for the Matplotlib. Now it is a part of Matplotlib. We are telling what should be the figure size to display this particular correlation now. And here data frame dot correlation, and here we are telling okay, this is all the format for you can say displaying the visualization. This is one of the exploratory data analysis. One of the feature is, and one of the visual method you are using, the heat map. Now heat map is a shortcut way to know the relationship between, again, correlation is something to relationship all the columns here to each other, and heat map is to visualize it now. It's a plotting thing. So here we are showing the heat map of the relationship between each and every column now. Now chances of admit is something which is here now. You can see chances of admit, and you can see there's a research. Now what heat map is telling you what is the observation of this which are the most important one, whether GRE score, TOEFL score, university rating, SOP, LOR, CGPA, research, which one is more related to the chances of admission here. So here we have these are the columns. Remember here chances of admit is something related to admission here. So which are related here? How they are related, each and every column now. Let us see this. So we are going to see the 3 most important feature here, which is included. See what will happen most of the cases, CGPA, GRE score, that is very common to all the students. But what is uncommon is you may not have a research part. You may not have done what you can say. There are some parameters which are very important to observe here. One is that how many guys have the research experience. You may have done because whoever is going for the master degree, you will see the common thing here, that GRE score, TOEFL score, university rating, and the statement of purpose, you can check it there. So, but what is important here, the research experience, you will see some candidate have research experience, some candidate may not have research experience. So this is going to decide your chances of admission. So we have to see which particular column or the factor is will be the deciding factor of chances of admission here, whether this particular GRE score or TOEFL score. So you will see, okay, most of the guys already having the GRE and TOEFL score. What is not there will be some of the column here. So whether letter of recommendation strength is there or not. So that is very important here in this case. So letter of recommendation also we are observing here. We are also observing the one more thing, that is a research experience, and chances of admission is all based on that only. So let us see that now. So this is what we are doing. So let us see the prediction now. What is the data visualization is saying? The majority of the candidate in the data set have research experience. Therefore, in the research, okay, so now it is said that as per the data set, that if the most of the candidates having the research experience, then in that case, what happened? This is an unimportant feature for the chances of admission. If it is already there, so in this case, what is saying that it is 0.8. Now let me do like correlation is something, it is related to like either 1, near to 1, or maybe -1, which is just the which is more related. So here, which is the most important score, that also we can see here now. So GRE score is telling you now here that it is 1 here for the GRE score. TOEFL score is 0.8. So which is the nearest one? Is these are the things which are nearest one. Which is a okay, only LOR and which is not there. Okay, research is 0.8, but which is near to 1, the other score which are near to 1. So the majority of candidates in the data set have the research experience. Therefore, the research will be an important feature for the chances of admit. The correlation between chance of admit and research was already lower than the other correlation value here. This is what the understanding based on the what heat map we saw it now. So these are the way you can now plot the data and find out how they are related to each other using the statistical tool here. Now you can find out the not having research and versus the research experience people. How many people is having the research and having the research now? So here you can see this is the even the this is not having research, you can find out, and having the research. How many people is having the research? You can find out here, and having the, so here we are plotting the X and Y, where we are plotting the that how many people here candidate is having the research and not having the research here. So not having research, there are 181 candidate, and having the research, there are 219 candidate here now. The lowest score is, so what we are doing in this case, we call exploratory analysis. From the data set, we are finding out each and everything. One by one column we are checking. In this case, we are finding out the candidate details, and the candidate here is saying that how many people is having the research and how many people are not having the research here. Then we are also finding out the TOEFL score here. What is the lowest score is there, and what is the highest score now? So let us find out that also, that what is the lowest score and what is the highest score here. And the methods which are there, like in the lowest TOEFL score is 92 and the highest TOEFL score is 120 and the average is 107. This is what you can find out from this data now. So here the TOEFL score is giving you like, okay, I just say these all columns are telling you the chances of admission now. So what is there here in this case? We are creating the y-axis where we are saying the data frame of TOEFL score, finding out the minimum value, then mean value. So whatever you see right now here, mean value. So these are all methods available in the NumPy itself, as well as in the data frame, you can see here. So you are finding out the DF of total score. This means you are calling the column TOEFL score, finding the minimum value. Then you are finding out what is the mean value, which is the average here, and what is the max value. So y-axis is telling you the minimum value, mean value, which is this one, and the max value. So it is so minimum value, max value, so we are just calculated in the y-axis here. X-axis we are just labeling here, and so minimum is worst, average is mean value, and max is the best here. and just plot here now. So TOEFL score. This is what generally we saw, the how many people are having. So here there are the lowest score is the TOEFL score is 92 and the highest TOEFL score is 120. So that is what the data set is now. Then the GRE score, it will tell you this is a histogram it will tell you the frequency of GRE score. The histogram will show the frequency for GRE score. So there is a density between 310 and 330. You need to use a various types of labels. So how you are finding the, this is like a plot. You can see here, this is a DF of GRE score, means you are calling the column GRE score in this case, and plotting and telling the type of plot here is a HIST. HIST is for the histogram. And you are telling the size of the figure and the beans, means the frequency here. This is the way you can plot the GRE score now. This is a histogram diagram. So what we are doing in all cases here, we are just analyzing the data, finding out which are the columns which are connected to, connected to the admission now. Then you may want to find out the CGPA score for the university rating. Same way you can find out now this is we are doing using the scatter diagram. We are plotting the scatter diagram in this case, CGPA score. How you are labeling? Again, the plot dot scatter diagram, and you can label it by titles, X labels, Y label, and you can show it now. So these all are the from where it is coming. It is from the Matplotlib now. So like that, you need to keep on exploring, each and every columns and see the, what is the minimum value, what is the max value, what is the average value, and you can plot it now. Now another graph could be a scatter diagram for the CGPA, and you want to say like which is greater than and equal to 8.5. We are finding out now CGPA which is greater than 8.5 now, and then you can plot it. CGPA greater than. So here we can also have a plotting of data, but with a condition now. This is a conditional plotting now. So candidates who are graduate from the good university are more fortunate to be accepted. So again, we are finding out now university rating in this case. Having the better university, so who graduated from the better university, there are more chances for acceptance. So we are finding out that also. How many candidates are there? So in this case, we are just plotting we are seeing the chances of admit greater than equal to 0.75. So this is like a condition, and based on that, we are finding out the top 5 candidate now. Candidate with a high CGPA score usually having the high SOP score also. Statement of, so this is something like you are getting a statement, and these are the way you can plot. I just want to tell you like how you can plot the various type of data once your data. So this is just one example like that. I did the various case study based on the requirement. I just wanted to show like how you do practically exploratory data analysis. So now here I'm just this is just like you have to try it out from the data set from the Kaggle, and there already case study. I will share this notebook also with the PDF so that you can try it out at your home also, like, and explore data, or you can try from the Kaggle site itself. So this was a brief about like how you can explore your data using the library called Pandas itself. I'll be taking the break here, and after the break, I'll show one more case study where I'll tell you like the sales data, where I did some work on the sales data. Some cases I did a work on the specifically one real case study is like a telecom domain. I work for the telecom domain. Then I also work for the energy domain for the Saudi electrical company. There we were finding out like whether to be the energy consumption versus the production. So this kind of problems comes, and you have to see like, okay, now how much energy production should happen. So it was like we were finding out for the complete year in the time series, how is the consumption of the people in the Jan, Feb, March, and based on that, the company were supposed to produce the energy. So that kind of case study also I saw it, but there it was like a data of almost lakhs of people. And there, from the lakhs of data, we were doing that works. It takes a lot of time when you do real-time data science. Here, I'm just telling you the brief about it, like how you can work out on using the library like Pandas, Matplotlib, as well as the library like Seaborn or NumPy library set, or you may have data set of, let's say, I told you like previous, like telecom domain, where you have churning customers, like whether a customer will retain or not, you want to find out. Uh, because most of the times what happen in the case of telecom company, customer are switching from one a particular network to another network. So the companies, want to predict that which are the type of customers they are more switching from one, from one network to another networks. So like, let's say from Airtel to the Geo, or Geo to the some other, let's say, Idea. So those customers, they want to find out well in advance. So that kind of case study is also there. Right now, I'll be taking the case study, which is more related to sales now, because most of you guys will easily understand the sales case study. And this is what I hope, like, the screen is visible to all of you now. This is what I'll be share, right now. Here, whatever thing we were discussing, there'll be a little bit repetition here, but then yes, this is what we want to do it in the case study here. Now this time I'll be taking the some concept part. Like I tell you, like, what is ADA? Is a exploratory data analysis. And why this we do it? We do it for understanding the data itself, what the data is all about, why this particular data is, how, and understand the problem statement also. So if you have a raw data, and using the raw data, if you want to find out about you want to get the meaning of the data, this is all possible by exploratory data analysis now. So here we did it actually. One of the action, like we did, like, in the case of the previous example of admission, there I have shown like how we do the exploratory data analysis now. We understood the data type there, and we saw like the different types of data. We saw like, the various columns we could find out. All these things we do in the exploratory analysis. Let me do. Generally, you always have two types of data set. One is called quantitative data, and another is called categorical data. Quantitative data, we saw it like in the previous example also. We saw like a numerical data you have, and it is having certain numerical data, you can say. And categorical data, where it is like some, let's say, string data, where you have cat, dog, or some value you want to find out whether it is the animal is a cat or dog. So all that kind of data comes under the categorical, where there's a decision making is there, or you want to find out the frequency. All that can be done in the categorical data. So, okay, this is another case study which I would like to take here, is about the sales here. This sales case study, let me give some context part for this. What is the kind of it is, so you understand this is again like taken from the Kaggle site only. Mostly whichever the example you will see, they are taken from some sources. So right now the source here is a Kaggle site. Now Kaggle, I already told you the spelling. You can just Google the Kaggle data set, you will get all the data and you can download it. But you may require to sign up there as a formality. And once you do that, you will be able to download the data set also. What this data set contains is a detail of a set of products in an inventory, and the main problem statement to determine the product that should be continued to sell and which product to remove from the inventory. So now what happened in the case of the company, which is a retail company, and I was actually giving this case study for the company specifically, which is into the retail domain, where they are selling certain products and they are showcasing certain products. Maybe you can take the retail store here, and the retail store, they're having several products available. Like, you can imagine here, anywhere else. I actually given for target company itself. The target company was having some retail store, and they wanted to find out that which particular product they should keep it into their inventory. All that they wanted to find out. For that, I thought, okay, let us now have a data set for that, and I have just done the analysis for the same. So data set here is having the set of products which include the inventory, and the main problem statement here is to determine the product that should continue to sell, which product should be continue to sell, and which product to remove from the inventory. There are chances that some products are in demand, some products are not at all purchased by the customer. So if some products are there which is there in your inventory but they're not purchased by any customer, what you will do with that customer? How you find out? For that you need to do analysis. Now what will happen in that case? You will keep only those products which are more in demand rather than keeping the products which are not at all in the demand. So this we can do it by this analysis itself. So in this case, the file contains the observation of both historical sales and active inventory data also. So we can see the what happened in the past 6 months or 1 year. This all we can find out, like, okay, which are the products which are more in use or which are more in demand, that we can find out from the historical data set. So when you say data set, it is all more historical data set only. You can find out, okay, for you have inventory, and through inventory you can find out that which are the products in your inventory, they are not purchased by any customer. There's no more demand at all from past 6 months, from past 1 year. You can find out now, okay, now in 1 year you find there are certain products which are not purchased or rarely purchased. Let's say maybe hardly in a 1 year, once upon a time, right, someone is buying them. So then those kind of products we can think about to remove from the inventory, or to not to buy also. So next time you will not buy those kind of a product and keep in your inventory then. So you can decide whether to keep it or not. Okay, so attach is a set of products in which we are trying to determine which products we should continue to sell and which product to remove the inventory. The file contains both historical sale data and active inventory, which can discern with the column title file type. So here file type is one of the column where you will see the historical sales data and the active inventory. Okay, so this is what the information about our data, whichever is given, we need to know the history, because without knowing the data you cannot perform any action on it. If you have some just numerical data, you don't know what to do, right? You need to know the column names, you need to know which are the column, what is the purpose. So here we are finding out more about the data first before we take any action here. We suspect that data science applied to the set, such as a decision tree analysis or logistic regression or some other machine learning model, can help us to generate a value or probability score for each product that can be used as the main determinant evaluating the inventory here. Now let me tell you, machine learning is giving you something model, is giving you decision, telling you like, okay, these are the product, I should keep it or not. It is based on the score now. So this all comes under the machine learning. My next workshop is on machine learning itself. So there I'll be covering the data science as well as machine learning. That workshop is only focused on the case study and then how you can use a model, various machine learning algorithm like linear regression, logistic regression. So here this particular workshop is focused only on the basic of data science and how you can use a library like Pandas and NumPy. But the next workshop is more on the machine learning. So here I'm not covering the machine learning part, but giving you idea, yes, if whatever the data, which is the Pandas, which is the most important data set, this data set is the input for the model. So you need to have first the clean data here. You need to have data, and that how you can clean data, how you can visualize the data. For that you have the library called Pandas, and you have the library called Matplotlib library. You have a library called Seaborn. So these three models allows you to visualize the data. When you say plot means having the varieties of the plot here. Your histogram, your bar chart, you have a pie chart. So all the types of plots are available when you look at the plot itself. Now, obviously, like based on the need, you may require to go for the plot here now. Okay, so I think this is about the column now. So before we go ahead with a data set and do certain exercise, we have a SKU number as a column. This is a unique identifier for each product. SKU number, whenever I'll be using that column name SKU number, like I'm defining the character here, and the character here are column name. So column name SKU number is the unique identifier for each product. Then there is an order, which is another column. It's just a sequential counter. This can be ignored. Then sold flag is having the one means for one for the sold in the past 6 months, 0 for not sold. It is just going to give the like a boolean value 1 or 0. So if it is sold, it is 1, not sold 0. And this is the data for the 6 months. That's why it's a past 6 months now. Marketing type is another column. This column is going to be where for two categories of how we market the product. This should probably be ignored again. Again, this is a categorical data. You may not require each and every column here. So you have to decide which column. See now, when you have a data set, you have maybe you may have hundreds of columns now. But all these columns may not be necessarily you will be using for for your decision making. Whenever you are making some decision, it is based on certain column only, and to identify which are the most important column to take the decision now, which are more correlated to each other. So we have to see the relationship here. So here correlated data is very, very important. If the data is not at all correlated, if something is not related to decision making, just ignore. Just keep those particular column then and focus only on those columns which are related to decision making. Because now what decision you would like to take in our data set, in this case, in this particular case study, is to find out the inventory here, whether which particular product to be keep it or in the inventory or not to keep it in inventory. Now this is what the decision you want to. So if this product is there in the past history, there's a demand, you want to keep in history, and something which is not in demand, you may want to remove it. So this is all we do in the case of sales here. Then there is a new release flag. So this is what the data set is. Now I have downloaded from here. This is the site from where you can download, like I have mentioned the size also, like in case you want to let me share this so that you can also download this. I just share this site here from where you can get the data set now. Now, first thing is here, I'm just creating one data frame by reading the data from where this, once you download this CSV file, you can read the data and create one data frame. Now, this is a data frame. Sales data is a data frame by reading the CSV file. Now, after importing the pandas as a PD, you can do this job now. Then I wanted to check, okay, once I have sales data, I cannot check the entire data. So let me check even how many rows and how many columns. So I can find out here. Now let us see the data shape here. It is telling you that it has 1,98,917 rows. And how many columns? It has almost 14 columns now. So now these many columns are there. So now in case you want to use all the column is fine, but then you have to see like which column to be used, what is the type, and this all we are doing in the EDA. That is what exploratory data analysis. Firstly, we are finding out what is the shape, means how many rows and how many columns. Then so this is what we did. Then I just find out the column's name. Now in this case, these are the columns, right? And these are the like when I say sales underscore data dot head, so it is having the top 5 rows here. When you say head, means it is having the top 5 rows. If you say dot tail, means bottom 5 rows. So here I came to know I just get in a glimpse of the data here when I take the sample data here. So okay, this is the type of data. I have a file type here, I have SKU number here, which is unique number, I have a sold flags as a 1 or 0, I have a sold counts and marketing types, and that is something which is mentioned here D here. So even I have mentioned there, like we may skip that point, release numbers and the new release flag, and then strength factor, pricing flags, releasing years, item count, low user price, and low net price. So these are the columns having some value. Maybe it's not interesting, but just to understand, like this is the way data set will be. Any data you take it, whether it is related to admission or education system, you are having the admission system and you want to process, you want to find out how many people are there, chances of taking the admission now. So this all can be done by doing the analysis now. So here you got the data where we say this many 1,98,917, that many rows, and these are the column now. So which are the columns? You can just say the data frame dot columns and you can find out the column name also. Now how many index is just telling you the rows. So it is just 0 to automatically can say 0 to 1,98,000, this many rows are there. So and now when you have such a big data, when you have the big data, you want to know about the type of data here, what type of data it is. So it is here informative statistics here. I want to know about it. I may want to know, okay, each column here, what. So here we have data in the lakhs now. Lakhs of rows are there and 14 columns, and each column I want to know about it. There's the order columns which is having 1,98,917 rows, and it is of the type integer 64. There's a SKU number, and this is having almost all rows available, and it's the type here is object type here. So when it is object type, you can see it is shown here. This file type is object type, and then SKU number is of integer type. Sol flag is for the float type. Sol count is. So this is the way we come to know the information about each and every types of column. And this is what we did. Simply we say whatever the data frame is there, dot info. That's it. Then in the descriptive statistics, you find out what the type of variable. Okay. So here are 5 definitions for the few of the column. Like file type is the value. Active means that the particular product need an investigation. And then the sol flag, when the value is 1, it is sale. 0 is for the no sale in the past 6 months. SKU number is unique. I already discussed about it, but again, like this is to quick look at it. What we were looking up the column now. So this column, whatever we saw, we are just having the quick understanding about each and every column. Then descriptive statistics. Descriptive statistics is something like you have so many number of columns. You want to find out the mean value. You want to find out number of exactly columns, count of the rows and all. You want to find out what is the standard deviation, what is the minimum value, what is the, so all that can be, and then what is the max value. So this can be find out by descriptive statistics. Now what will happen whenever you see the descriptive statistics, mostly numerical value calculation you will see here, because if you do not give it the include all, if you don't give the include option, it will do only for the numerical by default. That's what we did here in this case. In the previous case, we were having the previous case, I say include all, where all the columns were shown. Here we are just focusing on the numerical column now. Now there are some concept part like what is mode means, what is mean means, what is median means. In between, I thought to have some theory part here. So these are the statistical terms here. So there are 3 main numerical measure available, and which include the mean values, mean mode, and all these things. So what is mode means? The mode is the most frequently occurred value in your data set. In the numerical data set, if you have something which is a value which is most frequently occur, that is the mode value of the data set or the particular column. Now what is the mean means? Mean is the average value. This is very simple. How do you calculate the average? You know very well. And what is the median means? Is the middle value. Is the middle value. So you have to find out which is the middle value. That is what the median is. So again, like these all methods are already available to get the mean value and all this. So these are already available. So now, this is what I told. Like in case you want to describe with including all the columns, you need to just say include equal to all. Now here you can see even all the columns are taken care now. So what it shows in the initial state show like unique, top, and frequently. So here frequency. So those particular column which are categorical columns, for that you have a different way of describing it. You can decide the frequency or uniqueness, or all that can be done when it is the data is of categorical type here. So include all will describe argument display the descriptive for all the column. Now I already showed like sales data.shape, which is to tell you like how many. Now why I have again showing this particular method? Because now in this case I would like to see how many are empty here. Now here in this case there is a chances that some of the columns are empty here, some of the columns are filled, and so there are chances. So we have to find out now for every column, because here you have 14 columns. So in the 14 column there is a chances that one of the column is having some value which are duplicate, some values are unique. So which particular column is having what type of data also we can find out based on the unique now. Unique will tell you like, okay, now in the case of file type, only two categories of data is there. That also we can find a file type. We have only two categories. That's why it said two. Then SKU number is having the unique number. That's why it has a so many unique number you can see. But then some of the numbers are missing. So you can see out of the 1,98,913 SKU number should be supposed to be a unique here. So that also you can observe here. Let us have observation. Like data scientist is like observing. You just need to observe every column, how the things are there. The source flags is having just two types of the category here. Source count 37 category here. So you may have duplicate in this case. So unique are only 37. Then release number 71. Strength factor is yes, is almost like a same. It is very good, like in terms of uniqueness is concerned. So they are not, strength factor is not like a duplicate in this case. You have more unique value in the strength factor. Price price again, like you have more unique here. So this is the way you can find out the unique value here. Now again, like once you have data set, lot of way you can explore. You want to find out the data which is a historical data, or and then count how much data is a historical data. So there is a file type, and there are two types of file here. Let's say one is the historical file and one is the active file. So historical file is something like the past 6 months, whatever the files which are not used frequently. Let's say I would like to check. I would like to have one column will tell you like my historical record, and another column which is active record, which is there in the present. The particular inventories which is active inventory now. So you may have the retail store inventory which is active inventory. You may have a inventory which is a historical, which is not used in the recently now. So these are the, and you want to count. So there are, based on this you can find out that as per the historical category we have a 75,996 that many records are historical records, and the 1,22,921 they are active records. So that's a good news. Like, but then again, like imagine 75,996 they are not in active means, right? So this is the way we can find out like which particular items are in the historical and which is in active mode. So this is the file type is telling you now. So find out the number of active and historical cases. So we have these are the 1,22,921 active cases which need to be analyzed now, and then we can split the data set now. So now next case will be, okay, now we got certain record is a historical record and we have active. So we can split the into two parts, historical and active. So here we then split the data set into two parts based on the flag type. Flag type is telling you what type it is, whether it is a historical or active. So we need to find for that we will create one more data frame, and the data frame will be like sales data history and sales data which is active. So these are the two data frame we are creating now. So we are dividing the entire data frame into two types now, two categories, just two, because we want to analysis on some specific type of data frame, not the entire data frame. So that is not, because you may have so much of data, you may have a lakhs of record, but you may not don't want to examine each and every record here. You are going to examine which is more relevant to your decision making. So all the entries with the condition and create the new object with the required value. So we got this now. So this data set contains 1,98,917 rows and having 14 column with a 12 numerical and 2 categorical column. Now this is what the summary here, based on whatever analysis we done. There are 1 lakh, like how you do research, like a detective. You're a detective, you have to find out about data now. How much data is historical data? Data scientist, you are the data scientist. How much is active data? You're finding out now. And then you are saying, okay, this is the data having the 14 columns, having the 12 numerical columns, and the 2 are categorical columns, having the 1,22,921 active sold products are available, and which is where we are focusing now. So we are more focused on actively sold product. Not we are not focusing on which is a historical a record historical product now. So now this is the way you can get the data set, which is we are using it based on the type here, right? So file type, so active or so these are the way you can split the data and create one data set also. So here you can also see like the sales data. Okay, let me show you like this data frame now. This is a data frame. Okay, act. I can see the shape also. Okay, I have to run all the queries, otherwise it won't run. So I may require to run all the queries here. So I have run this query here till now. Let me check whether I run all or not. Without running, I cannot run the other query also. This one is also important. If I run this, I may require to check this one. Yeah, now you can see it. So I got like this many, obviously the rows and columns, right? Again, if you want to know, okay, let me print this. This was to get the shape here. Now you understood like why I'm using the shape method here, like cells. This is just the data frame I'm focusing, let's say, which is active record data. So here I want to know, okay, you can describe also separately, but then this is the one new data. Just check the head section here now. It has okay, so this is the record which is active record. You can see now I have taken the record which is of active record now. So cells underscore data dot active, and just want to show that okay, this is a data frame which is split from the historical data. Very simple command. Just by writing the logic here, like file type equal to the value is historical, then we got a data frame of historical. When you want to have a data frame of active records, we just say active here. This is based on the value now. So this like a data frame is divided two category here. Now here this is the way we have active record now. Again, you are also finding out another thing is the marketing type. This is another thing. Frequency of distribution of marketing type. What is that marketing type? Sold or so understand there's a one more there are one more column that is a marketing type itself. See the marketing type. There are two category only. What is this category is telling you? Sold or yeah, this is marketing type. There are two category only. Let us see the what marketing type is here. In the beginning also I have shown you. Yeah, these are the category of how we market the product. This should be probably ignored. Okay, but then this is like the type here. There are only two categories are there now. Yeah, D and S. They are the marketing type here. And again, based on that D and S, you have you can see the category of D and S type here. You can also have something like, you want to create a one data frame based on the column. So like that, you have to keep on performing the action. I'm just showing some of the, not all the, because see here, in case you want to select certain column like strength factor, price release, all these things, and then you want to perform the plotting of the data, a lot of things are possible here. Okay, so this was to tell you like how we can, perform the various action on the this particular data here. There are a lot of plottings are there, then yes, visualization, then correlation, and then drawing the heat map here specifically related to like the columns which are more important to you and which are connected. So this gives you the idea here now. Okay, so this is all about to give the idea about how exactly you can, you know, perform the descriptive statistics or informative statistics on the particular data here. If any question, let me know. This is just to give the idea, and there are obviously there are some concept part to understand here, like you may require to understand the statistical concept, like what the standard deviation means, correlation means, outlier means. All these concepts are very important. Let me give certain idea to you so that uh, I'm just sharing the some concept part here, and here I'm just sharing this. See, there are, when you look at the statistics, talk about the various things: descriptive statistics and inferential statistics. So numerical, where we talk about the descriptive statistics, or is more about the numerical descriptors for the finding the mean value, standard deviation, and then find the frequency, percentage. All this comes as a theory part here now. There is a inferential statistics also used for drawing the meaningful conclusion here about the entire population. So that comes as a inferential statistics here. Yeah, so I'm not discussing this theory part, but yes, these are the theory things which you may require to look at it. Like there are some concept related to outlier. Outlier is something where some data which is not in the same sequence. It is something which is exceptional, right? So is where you find like it doesn't fit into your data set now. So you may require to find out how many data, how much is the data which is not fit to your data set. So that is what we say outlier. So this is example, like for example, this data. One of the point you see here, you may have such sample data which is not in your in a range. So it's exceptional data, you can say. Okay, so the mean is arithmetic mean, and the statistical mean of the set of. Okay, this is something which is very simple to understand how to get the mean value. More I told you, like, is defined for the most frequent element in a set of element here. For example, we have 1, 3, 6, 6. In this case, 6 is like frequently is a number which is frequently used here now, right? So that's why here the mode is 6 in this case. Then there's a median value. In this case, the median is defined as the middle element or the value separated by the higher half of the sample from the lower half. So here the median in the case of 1, 1, 2, 4, 4. So the median value is something which is 2 here in this case. Then there are the concept like variance. What the variance means, the difference between the your what are the averages there. So there's a lowest value and there's average value. So the difference between that is a gives you the variance name. Like that, there are many more statistical terms are there. You may require to go for that. There are concepts related to correlation. It is correlation is between the showing the relation between the two or more variable. Means to how these columns are related to each other's. Mostly, there are two types here. Mostly you see the correlation measure is like the either negative or positive correlations is means they are affecting here. So your particular columns, how they are affected is because when you say negative means -1 value and positive means +1 value, and these are zero means is a no correlations. Zero indicate there's no relationship then. Okay, so this is what the basic here. Again, you may require to prepare all those things. Okay, there is a one question which is read like how to create a model. Okay, let me answer here. But although it is a part of machine learning, but model is related to machine learning. For that, you will require to go for the sklearn model. Is a library which is there in the machine learning. There we create a model. So you require to have a training data set, and using the training data set and the testing data set, you will require to create a model there. Model is all about machine learning here. I hope you got certain. Okay,